Well, let's get into the next part of networks, and that is, as you can see, scheduling problems. So you've done your precedence tables, you've drawn your networks from precedence tables and drawn your precedence tables from the networks. Great. Now we're going to talk about the timing of things. So ultimately, if we've got a set of jobs we have to put together to create one outcome, then we have to work out what goes where and when. Now, specifically for this one, it's about the when. So these are the things we're looking at today. We're going to be using weighted precedence tables. So that's just about the time or the number of things or how volume of things. It could be any sort of measure. We're talking about float times. Now that's about if we can delay some activities. We've got a little bit of float time. We could hold off finishing an activity. We've got earlier start times, later start times, and of course, the critical path. Let's have a look at what those mean. First up, we have a precedence table. You've all seen this before. The activity, its immediate predecessor. We're going to change this now. We're going to add the weights to it to make it a weighted precedence table. That means we add a column, which is, in this case, it's time in hours. So how you read this is activity A takes 5 hours to do. Activity B takes 8 hours to do, but cannot start until activity A is finished. Same with C. Can't start until A is finished, but it takes 4 hours to do. So let's draw our network from it. So same way, start with the start vertex. First activity is activity A, which goes for 5 hours. So we draw it the same way, a directed edge with the A, but we write comma 5, which is our weight. Activity B comes off A and is 8 hours long. So activity B comes off A, there it is, B, which is 8. C also comes off A, but is 4. So because it comes off here as well, I'm going to draw it down this way. C takes 4 hours. D comes off C, which is 6, straightforward. There's C. Here comes D. E comes off B, which takes 3. So that's great. But I just noticed, look here, F comes off D and E. So there's D. E comes off here. So I think I'm going to have to join this up. So I'll put E between here and here. There we go. There's E, which is 3. Now F comes off D and E, so they've come together, which is great, and takes 2 hours. All right, there's F, that's 2, and we have our finish vertex. Great. All right, what do we do with that now? We're going to try to figure out how long it's going to take to complete the whole job. All right, let's have a look at this first one. A takes 5 hours. So up to here, it's taken us 5 hours to complete task A. If we go along this path, up to here, it's going to be 5 hours plus the 8 hours, which is a total of 13 hours. If we come down here from there, it's going to be obviously another 3 hours. So 13 plus 3 is 16. All right, we've got to a junction here. Let's go back here and see what this one does. Now we've taken 5 to get to here. This is another 4, so 5 plus 4 is 9. Then we have the 9 plus the 6 here, which is 15 hours. Now you can see what's happened. This is 15 to here. This is 16 to here. We have to decide when we start F, because F relies on both of these things happening, doesn't it? So here it is. Cannot start until both activities D and E have finished. So D is 15, E is 16. F can't start until the 16th hour has finished. So that means we've got an hour of play in here. We don't have to think about what we do down here for an hour. We can go have a cup of tea in one of these activities. F must start at 16, goes for 2, and gives a total for all the activities combined of 18 hours. So we write the whole process takes 18 hours to complete. Now there is a more scientific way to do this. This is one way. There are a few around and there's a few different shapes and ideas, but principally it's the same thing. This is just one way I'm presenting to you that makes it fairly easy to follow. There's quite a few steps. We'll do a couple of examples, starting with one here, and then we'll go into a slightly more difficult one from scratch. All right, first thing we need to look at over here, we're going to do what's called forward scanning. So that's where we draw two boxes side by side next to each vertex. So here's our first vertex. We need a double-sided box there. You can see we're going to put them all the way through the network at each vertex. Where exactly doesn't matter, so long as you can see that it references the vertex. Second step, we're going to write in our earliest start times. So we're going to use this first box as our earliest start time. Now, obviously the start is going to start at 0 hours. So here's just an explanation. Start is going to start at 0 hours. Start that again. So we go from here to the next earliest start time for these two activities, which is going to be here. So we take the 0, we add the 5, and that becomes a 5 in there. Let's work our way along here. 5, we're going to go down, add the 8, and the answer will be 13. We added in there. All right, that's where we go next. We'll go down the way. 5 plus 4 is 9, which will come down into the box here. Now, you'll notice we have a junction down here. I'm going to move this pair of boxes down a little bit because this is the trick that I like to do, which makes it easier to see. Let's have a look up the top here. I've put a 16 there. Where did that come from? That came from up the top arrow in, the top edge in, 13 plus 3 is 16. I've got a bottom edge here, which is 9. Add 6, it's going to be 15. So I'm going to write that one down the bottom. Now, this is the important bit. For earliest start time, we actually want the largest number of these two, which is obviously 16. Now, it could be 2, could be 3. It's pretty rare you get more than 3 in VCE, but you put the largest of the numbers outside and it goes in the box. Put this one up top because it comes from up top. This one down the bottom because it comes from down the bottom. So you can follow where it comes from. And the last one, obviously, we go 16 plus 2 is 18. All right. Now, it's time to start working backwards. Latest start time. Working backwards, we start at the finished vertex, where our latest start time is equal to the earliest start time. So these two boxes will always end up being the same. We work backwards by subtracting the activity length from the latest start time, from the previous latest start time, that is. All right, so let's put the 18 in. So we're going to work backwards. The 18 take away 2 is going to be 16. Great. Now, we have a choice. We can go up or we can go across. Which way should we go? Let's see. Let's go across. 16 take away 6 is 10. Let's go up this one. 16 take away 3 is 13. Now we've got a junction going backwards, haven't we? Well, let's move the box up a little bit. All right, what have we got? We'll start with the 13. 13 take away 8 is 5. Put it on top of the box. This way, 10 take away 4 is 6. Put it below the box. Now, remember how I said the largest time is the earliest start time? Going backwards, we want the opposite. So we want the smallest time in the LST. 5 or 6, the choice is 5. 5 take away 5 there, comes back to 0, which is what we want. Confused yet? Don't worry, it becomes obvious when we do it a bit quicker. A couple more things we need to look at. The fourth one, is the critical path. Now that is the path between the start and the finish where the earliest start time and the latest start times match. That is the path that determines how long the overall job is going to take. Okay, so obviously we're going to start at start. The first pair of boxes that match is here, so we're going to go from here to there. The next pair of boxes that match, it's not down here, it's up here, so we're going to come along to here. Then the boxes match here, so we'll come down here, and finally to the finish. Okay, that is our critical path. That helps us find any activities that we've got a bit of float time on. Remember we're going to have a cup of tea? That's float time. So this is the amount that an activity can be delayed without slowing down the whole operation. It's calculated by doing the latest start time minus the earliest start time. Now, one thing to remember, activities on the critical path, so any of these with the green line, they do not have any float time. Their float time is 0. They can't be delayed. Okay, just something to remember. It's a typical exam question. Let's have a look at this. So our critical path was A, where are we? Over here, A to B to E to F. So we've got that down and takes 18 hours. Great. Now, activity here, up here, we have C and D have a float time of 1 hour. So activity C starts here. Let's have a look at this. There's a 6. That was where the latest start time of activity C. That's why it's handy to put it down below. 6, take away 5, gives you 1 hour. Down here, you can see the difference, 9 and 10. Okay, 10 take away 9 is 1 hour, as it says in the equation. All right, it becomes a little bit easier in the next network we'll have a look at. Okay, let's just quickly analyse. Same network as we did before, but we'll just pull it apart a little bit, a bit more space. All right, first thing, the critical path goes from A to B to E to F. A to B to E to F, great. Second thing, we're going to look at the time it takes to do all the activities. So the 5 plus the 8 plus the 3 plus the 2, or we can just look at our LST back here, and that is 18 hours. All right. Now, the third bit of information is, as I said just before, our float times. Now, I'll just remind you that that's LST take away the EST, and I'm going to show you more closely which numbers to subtract. We can see up here, the numbers are different. We've got the 6 there on that path, and we've got the 5 there. You can see the 5 and 5, they're the same. That's up on this critical path. The 6 down here is different. So that refers to activity C. So activity C, its LST is 6, its EST is 5. So just down here, 6 minus 5 is 1 hour. The next activity, which is not on the critical path, is activity D. So you can see more quite clearly here, our numbers are different. So activity D has a float time of, our LST is 10, our EST is 9. So again, 10 minus 9 is 1 hour. Does that make it a little bit clearer? Let's do a slightly longer example. And this one has an odd path in it. See if you remember what it's called. Which one's the odd one out? Correct. It's this one. It's got a D in it. Coincidentally, comes off D. It's D dash. That's called a dummy path. That simply means if we had a precedence table that J and I would have to wait until D and C have finished. But G doesn't have anything to do with C. It only comes off D and E. So we've had to join that up with a dummy path. you can see the weight of a dummy path is 0. Okay, that's important, very important. All right, first thing, let's analyze this. Given the network below, determine the critical path and the total time taken to complete the job, and list any activities and the amount of time that can be delayed, so float time, so that the overall time is not impacted. All times are in minutes. So where do we start? First thing we do, forward scanning. Let's draw our boxes. Here they come on every vertex. Now I've given myself, particularly at these junctions, I've given myself a little bit of room. This one has 3 in it. As I said, it was possible. Three edges coming into that vertex. So I'm going to have to put a number there, and a number there. Leave yourself room for them. All right, where do we start? We start at 0 over here, the earliest start time. Let's put it in the box, 0. Let's work our way around. Activity B, so come down here. Our earliest start time is going to be 8. Activity A, I did B before A. Doesn't really matter in this case. Activity A up here has 10, so that'll be a 10 up here. Oh, let's see. There's a vertex. Now that comes off there, but you see this one has another one coming into it too. So I'm going to write my numbers top there and bottom there. Let's see what happens. 8 plus the 1 is 9. So we write it below. And coming down the way, 10 plus 6 is 16. So it goes there. Now, earliest start time was the largest start number, wasn't it? So the larger of 9 and 16 goes in the box. Okay, let's trundle along. Let's see, where should we go now? Let's go up to here. This is 16 from here, and we have no time increase because it's a dummy. Goes up 0, becomes a 16. Also has C coming into it, so that is 10 plus 7, which is 17 up there. Largest number goes in the box, 17. Okay, now let's go down to here. Seems a logical place to come. Now, top arrow in here, I'm going to put up top. 17 plus 7 is 24. Middle arrow here, so we've gone from 16 plus 4 is 20, so that'll come out the front. And this one down here, 8 plus 12 is 20. Put that down the bottom. Biggest number is 24, so it goes in the box. Last vertex. Let's come along here. Now we've got 2 coming into it, so we're just going to do top and bottom. Let's do the bottom first. 24 plus 5 is 29. 17 plus 8 is 25. Bigger number is 29. So there's our completion time, 29 minutes. Next thing we do, we'll work backwards and find our latest start times. LSTs, so matches in here, so 29, working straight backwards. Now let's go this way, 29 minus the transmission time, we can sometimes call it, or the weight. 29 minus 5, of course, is 24, goes straight into there. Now, let's have a look. Let's go up the way. 24, take away 7. That's the bottom arrow which goes in, so the number's going to go down here. 24 take away 7 is 17. 29 came from this one. Take away the 8, goes up top, is 21. Now remember the latest start time. What goes in that box? It is the smallest n number. So, smaller one is 17. Looks like that's going to be on the critical path, doesn't it? The numbers match up. All right, let's have a look down through here. Okay, so this has got 3 ways into it as well. No, it's only got 2 ways going backwards. That comes out of it, sorry. 17 take away 0, and the number's going to go up top. So that's just 17. Now this was G was 24, later start time. Take away 4 is going to be 20. I'll put it just in there so it's obvious. Smaller number is 17. 17 it is. Now, which way? Let's go up. Doesn't really matter. We're all going to end up back here. 17 take away 6 going up the way. So 17 there, take away the 6 is 11. This way, 17 take away the 7 is 10. So the 10 goes in the box. We better come down here, I think. Let's see, 17 take away 1 is, oh, that's going to be up the top, isn't it? So 17 take away 1. No, let's do this one first. It's from further back. 24 take away 12 is 12. 17 take away 1 is 16. Smaller number goes in here, so it is 12. Let's back up the front, back up to the start vertex. We're at 12, take away 8 is 4. 10 take away 10, that gives us our 0, which is back to the start. Okay, now we've got all of our boxes filled in. You can see it doesn't really matter which way you go. Try to move right, left to right going out the way for earlier start time and right to left coming back. You will end up back at your start vertex eventually anyway. Next step is, of course, the critical path. So let's match up the boxes. So 0, 0 is where we start. Obviously, we're going to go up to 10, 10, where the EST and the LST are the same. So up to 10, 10. Next step. Now, do we come down here? Do our boxes match up? No, they don't. Up here they do, 17, 17. So up to there. Where do our boxes match up? Now here we've got a bit of a dilemma. Yes, we could go straight down here, 29, 29, but have a look at these boxes. They also match up. This way is longer. So we have to come down here and match these boxes up and then go straight through to the finish. So we can say our critical path is A, C, I, and K, and takes 29 minutes. Well done. Last one we have to look at is the float times. Now, remember what the float times meant? It was the LST take away the earliest start time. So let's work our way around. How do we pick the ones with float times? We've highlighted the critical path. So we have to just work our way around and pick up all the activities that aren't on the critical path. So there's B, there's D, there's E, there's F, there's G, there's J. Don't have to do D dash, all right? Don't worry about D dash. That's just a connector. See, it's dashed. Makes sense, doesn't it? All right, let's start with B. Okay, B has a float time. So where does B start? What's the latest start time for B? It's 4. What's the earliest start time for B? Is 0. So B has a float time of 4 minus 0, which is 4 minutes, as you can see here. Next one, B, let's do F. Okay. F has a float time. Where does F start? It starts down here. So F was the bottom arrow, the bottom activity, sorry. So that's down here. There's our latest start time. There's our earliest start time. So 12 minus 4 is 8. Well, we're down here, so I might as well do E at the same time. So E has a float time of, well, there's the start. So it's the top one. So 16 take away 8. 16 take away 8 is 8 minutes over here. So a long time to sit and wait. 2 cups of coffee. I've had coffee from tea. Oh, okay. Next one. Where are we up to? Let's go. Oh, we've done this vertex. Let's do this vertex up here. D. Has D got, D's not in the critical path, so it has got float time, doesn't it? Where am I looking for the latest start time here? There it is. D is at 11. Is the latest we can start. Earliest this can start is 10. So that's 11 minus 10, which is 1. Next one, let's go to G. G is there, that's where it starts. Its latest start time is 20. Its earliest start time was back here in yellow, was 16. So 20 minus 16 is 4 minutes. What's missing? We've done B, F, E, D, G. B, F, E, D, G. Yeah, it must be J. J is the one that's left. Okay, remember, J starts up here. It was our, let's see the bottom, that's the top. So that is our top one. 21, take away the 17. So 21 take away 17 gives us 4 minutes of float time. Okay. You can see how it all starts to flow. So steps, forwards, draw your boxes, forward scanning, and it's the largest start number, as you can see. Second point is, so you've done your earliest start time, then you get to the end, you work backwards using your latest start time, figuring that out, which is the smallest number. Then you do your critical path, mark that off. Then you find your float times, all right? 4, I've written 5 there, put the forward scanning in just so you draw your boxes, but the 4 steps, earliest start time, latest start time, critical path, and float times. Hope that helps. Plenty of practice. It really does get simple when you start doing it, but be methodical about it, please. Don't skip any steps. Good luck with it all.